Hello students, Anuruddha Kempitiya again. In the last section, we discussed how to measure the atomic masses or molecular masses, and then how to work out the average mass and where do we find that average mass. In the periodic table, we find that. Okay, when we take that average mass from the periodic table, uh, what is the method, what is the appropriate methods to express these masses in chemistry? Right, there are two methods of expressing these masses. Okay, one we call mass of a particle in atomic mass unit. Okay, atomic mass unit is a very tiny unit used to express the masses of tiny particles, matter particles, atoms, molecules, ions. Then we use kilograms, grams and milligrams in day-to-day use, day-to-day life. These are very large compared to the atomic scale. When it comes to an atom, it's very tiny. But kilogram is a very large unit compared to an atom. So if you express the mass of atom in kilogram, that is not appropriate. You are getting very small value like this. This is very small. This is very difficult to use, inconvenient to use, and difficult to compare, difficult to use in calculations. But if you take these kind of values, they are much more convenient. Then these are the two methods: mass expressed in atomic mass unit, and you can use the same value but without unit. In atomic mass unit, the symbol of unit is U, but in this method, that method we call relative atomic mass, relative molecular mass, or relative formula mass. We don't use a unit, that is much more convenient. Then for an atom like chlorine, you can use this method 35.5 U, that is mass of a single chlorine atom, one atom. And mass of one atom also 35.5, then we call it relative atomic mass. When it comes to Cl2, that is not an atom, it's a molecule. So relative molecular mass. Then carbon dioxide is compound molecule, that again relative molecular mass. Sometimes we use AR equal 35.5, MR equals 71, MR of chlorine equals 71, right. Now we will talk about an ionic compound like sodium chloride. Sodium chloride is an ionic compound and it is not a molecule. It is a non-molecular substance. That is a giant ionic lattice. This is just the formula unit represent the simplest whole numbered ratio of ion. So we don't call sodium chloride molecule. Instead we call sodium chloride formula unit. Then its mass is relative formula unit mass. Even sometimes we give empirical formula. Say empirical formula of benzene. Benzene is the real molecule. It has 6 carbon and 6 hydrogen. Ratio is 1:1. Then that simplest whole numbered ratio of that molecule is given as CH. That is called empirical formula. That mass also we can calculate. That's 12 plus 1 is 13. 12 for carbon and 1 for hydrogen. Then 13. That's also we call relative formula mass. Mass of empirical formula also relative formula mass. So these are different type of matter particles we find in chemistry, and maybe we can use matter units or particles, isotope. That's a single isotope. This is the average mass of a chlorine atom. You get it in the periodic table. And this is the sum of average masses of two chlorine atoms. That is also you are getting. This is sum of average masses of carbon and two oxygen atoms. That mass also you are getting from the periodic table. And these are also average masses you get from the periodic table and get the total of two atoms. Right. These are the then two methods. What are they? We can express it in atomic mass unit or same value, same number you are writing without unit, then you call it relative atomic mass, relative molecular mass or relative formula mass.